This is Mission 9, Experiment 1. We have Robot Shiner here. We're going to have it do the lollipop-shaped GPS waypoint. Motion script. Robot is sitting out there, ready to go. Over here. I have my laptop. We're going to talk network with it. We're going to start the client. It just sent the motion script. And now I just sent the motion go. See how the robot moves. Robot Shiner is moving quite haltingly. Made it to the first waypoint. This is Mission 9, Experiment 1 with Robot Shiner. Notice that it can't quite reach the maximum speed. But at least it is able to reach the waypoints. It's going in the right direction, and it reached the first waypoint. Looks like it just reached the second waypoint. And now it should be turning. We can see that it is turning. So I believe what's happening right now is the software on the microcontroller is actually programmed to halt the motor if the tachometer is not reporting a reasonable value. So what I suspect is the tachometer is not working on this robot, and that is why the robot is running in a very halting manner. So when we get the robot back here, we're going to see what's up with the tachometer. The log file should also indicate what the tachometer readings are every 1.4 seconds, and so we can look at the log files to find out if the tach is indeed the culprit here. You can see though that despite the tach not working, the robot is still reaching all the waypoints quite nicely. So nothing physically seems to be on your cable. Evaluate to see if that is. This is waypoint number 5. Now this is interesting, and all of a sudden the robot started to run smoothly. That's almost as if the tachometer suddenly started to work. So when we get back the data, we're going to have to see along the way to waypoint 6, did the tachometer reading suddenly become reasonable? It appears that the halting behavior has resumed, so perhaps not. Actually, it is running smoothly now. So it's possible that the tachometer signal is now valid, and that's why it's able to run smoothly. Robot timer here has just reached waypoint 9. Oh, sorry, waypoint 7. And now it's heading towards waypoint 8. The halting behavior has started again, so we'll have to analyze the tachometer. Another reason why I suspect the tachometer is faulty here is because the acceleration is much faster than we programmed it to be. And the only reason why it would accelerate so fast is if it thought it was going to slow. Maybe the tachometer is getting zero speed. So the robot just reached waypoint 8. Again, this is Mission 9 Experiment 1. The robot we're using is Shiner. Robot Shiner has reached waypoint 9. There are two more waypoints left. It is still running in a halting manner. What that means is it tries to accelerate, but then all of a sudden the motor power is cut off and the robot rapidly slows down, and then the robot resumes trying to accelerate again. And a possible cause for that is the tachometer is not reporting the correct value. It could be reporting 0 the whole time, and that's why the robot tries to accelerate so fast. Yet there's a safety mechanism built into the software and the firmware on the microcontroller that cuts off power if the tach diverges too far from the actual power that's being sent to the motor for too long. Now, as the robot approaches a waypoint, you'll notice that the halting behavior stops, and the reason for that is the divergence between the tachometer reading, which might be 0 the whole time, and the speed that we're trying to send to the motor actually decreases because the software is programmed so that as it approaches the waypoint, it slows down. Once it slows down, that safety trigger that cuts power to the motor when the divergence between the tachometer and the actual speed is too great, that's actually disabled because the divergence is not beyond that threshold when it's running so slowly. Alright, so the robot was able to follow the motion script. This is experiment number 1 of mission number 9. It was a successful run except for the halting behavior that we're going to try to debug next.